Welcome to you all. Thank you for joining. Today, you've joined the WebEx Unlocking the Potential of 3D Printing. You've joined the free webinar on additive manufacturing. There will be an opportunity to ask any questions that you may have at the end of the webinar. So if you're happy, please wait and save your questions up for the end. Also, just so you know that the webinar is being recorded. You are all on mute, so you can sing merrily away in the background and no one can hear you. In the description of this webinar on Eventbrite, we asked, are you curious about 3D printing and its potential to transform your industry or your organization? Whether you're an entrepreneur, an engineer or a business leader, this free 15-minute webinar is your gateway into the world of additive manufacturing, and an exciting and exclusive preview of our up-and-coming 2-day workshops at the Space Park Leicester, part of University of Leicester, of course. So here you are. Hopefully that's the reason you've joined, and you're not here because you want to learn Pilates or something equally informative from the Eventbrite program. You are in the right place, and we are going to be talking about 3D printing. So thank you for joining again and sharing your valuable time with us. And just as a sign of our appreciation, we will offer something very special for those of you who have joined the webinar today. Following the end, an email will be sent out, and hopefully that will encourage you to join us for one of the 2-day events that we will be holding. These series of workshops are a continuation of an investment made by University of Leicester in 3D printing as part of the STAR project back in 2020 and 2021. Leicester University purchased a range of 3D printers that are still in the university, and they were sort of brought in, all capable of engineering grade composite products, suitable for use in commercial and research environments. They also purchased a 3D scanner to create 3D models from manufactured components or parts that they already had, so that they could be reverse engineered. And reverse engineering is basically having a part that you have, making copies of it by 3D printing. Of course, you need the scan CAD to do those prints. We'll get into a bit of that later, and of course, even more so on the workshops. The STAR project was tasked to upskill local manufacturing industry. So as part of the STAR, a series of workshops for local SMEs were undertaken, and these facilities were used to demonstrate the capabilities and opportunities offered by advanced manufacturing. And as one of the awarded suppliers, we had the opportunity to take part in these workshops and assist University of Leicester staff in demonstrating the capabilities and opportunities offered by these printers. The workshops proved successful, and now additional dates have been scheduled, and that's what we're discussing today. This really brings us to the when. The workshops are on the following dates: the 14th and 15th of May, 23rd and 24th of September, 27th and 28th of November. What will we be talking about? Well, obviously 3D printing, but essentially the workshops are designed to transfer knowledge to delegates, so they can gain an understanding of professional additive manufacturing technologies, and so helping small businesses gain knowledge to develop their own processes and products in their businesses using 3D printing. We did it in the first series, but now are keen to extend into the new series, a practical action. These are not only hands-on activities during the workshop, but also some post-event consultation that promotes engagement of technology and consideration as to how you might introduce this technology into your own business. Why are we doing the workshops? Well, as I said earlier, they were previously done as part of the STAR project, and they proved successful. Also, the feedback we received was that information provided was unbiased, and we can understand that if any of you have engaged with the original equipment manufacturers, Markforged, Desktop Metal, 3D printings, 3D systems, Stratasys or HP, to name a few, you would be able to obtain information from the respective salespeople, but perhaps not from a perspective which might result in you obtaining the most appropriate equipment for your organization, but even just often there's a level of knowledge you need to have to engage in those conversations, to be prepared for those conversations with OEMs. These discussions will need a level of information that helps you inform your needs as a business. So these workshops will help. Who should attend? I suppose it's likely you've heard about 3D printing before and you're interested, hence you're on this webinar. But perhaps you want to know more about how it works and how it can benefit your organization. You won't be alone in that many managers and business owners have heard and have seen other organizations using 3D printing, but perhaps wonder how it might be useful to them in their manufacturing or product development. And if this is the case, I'd say not only is it a good choice you've joined the webinar, but certainly the workshops will be useful for you in the future. No prior experience is necessary. I suppose just a curiosity and a desire to explore how it might affect your business positively in the future. I'm mindful that even in the first few minutes of this webinar, I've said 3D printing, I've said additive manufacturing, I've called it AM. The definition of additive manufacturing is essentially joining material, usually layer by layer, to build up a part. So the technology gets called many things, but globally it's known as additive manufacturing. The workshops will be delivered by me. I'm Nathan Blake, and I've been involved in 3D printing for 10 or 12 years. The company I'm a director of is 3D Matters, and we really came from creative roots, I suppose, supporting advertising agency, design agencies in the past, that have and engineers and product designers wanting customized, low volume, high quality products, and that led us really into the technology of 3D printing, and certainly now is the best way to turn ideas and designs into physical products. Whilst 3D Matters is primarily a technology and hardware materials provider, we do offer project support to customers who want ceramic or metal parts, but it's a very niche market, and not everybody will be interested in those materials necessarily. And I'd say our biggest area of growth currently is post-processing of 3D printed parts. Would you believe? This certainly is an area where the OEMs have forgotten or traditionally neglected additive manufacturing, the post-processing of parts. So this is where lots of customers need assistance. I suppose the journey for looking after or looking at 3D printing starts with a little inspiration. 3D printing isn't just about producing something that you already produce cheaper as a way to gain an advantage. However, it might be that it can be made cheaper, but this will be a result of a design iteration or even a a development of the product to make it better. In most cases, something that is mass manufactured won't be cheaper by 3D printing per se. If you need some help to get a little inspiration, it's worth taking a look at some general ideas. You can try Googling 25 unexpected 3D printing use cases, and you'll find some really interesting results that will definitely worth be checking out, and can help you get your creative juices flowing. But essentially, to find your own inspiration and innovation in your own business context, do you as a business want to do any of the following? Do you have an idea that you think could be a great product, something that you can develop as a business? Do you have a product that you want to change, that you currently produce, and you want to make it better? Iteration is a great way to look at how 3D printing can help. Do you have a manufacturing process that has a bottleneck, or do you think there could be a possible improvement so that you can make your product faster? Do you need to communicate a design or a concept to someone and want to show them a physical example? Do you have a product which you need relatively small volumes of but are highly customized? And finally, certainly during COVID, this was a huge reason for uptake in 3D printing, really the use of suppliers for parts and components, but do you as a business want to produce them yourself? And in COVID, that certainly was an active motivation for many companies taking up 3D printing. They just wanted to control the supplies of their components. These are all really good reasons why 3D printing may help your organization to become more competitive. And as part of the workshops, there's an opportunity to discuss with us how 3D printing can be utilized to ensure that the best outcomes are achieved in your investigation in 3D printing. If you think there is a manufacturing or product design problem in your business which needs solving, we can discuss this further. There's a post-course 1 hour consultancy session included, which might help you get the ball rolling. So you've had the inspiration, you've got an idea, and you need to make your product and turn this into a physical thing. The question is, could 3D printing help produce your idea, or are there conventional processes that would be better, not so good, or even in some situations possibly complementary? We will investigate this further in the workshops, look at product life cycle and how 3D printing can help you fail faster. And surprisingly, in the engineering world, this is what is what's tried. What we're trying to achieve is to fail faster, and this enables learning and innovation, which is key. So let's say you decide to use 3D printing as the process. This will start with a CAD file. You can see here on the left side of the screen, CAD scan online. They're all ways of obtaining files. We talked about the 3D scanner that Space Park Leicester obtained. That was to reverse engineer. There are also additional details on this slide, which we will go into further during the workshops. But let's keep things simple for today. Essentially, we need a 3D CAD file, and imagine designing a cube, for example, in a 3D CAD software. What happens in 3D printing is these are sliced. This cube is sliced into little layer cakes, and placing each layer upon the other, you can form the finished cube. This slice file goes to a 3D printer, and the 3D printer will put down a layer at a time till the part is completed. And there are many ways, many different types of 3D printing technology, which we'll cover in the workshops in greater detail. However, fundamentally, each technology has an energy source, a material to form with, and a platform to lay the material onto. This is generally the requirement of any 3D printer. Of course, we'll look at subtractive versus additive manufacturing, and consider each process to make a decision for each application, which might be best. As an example, could it be here on the top diagram where you have a material block, subtractive manufacturing, for example, a CNC or a lathe is used to carve out your design, and you end up with a part which has less volume than the original material that you provided, or than you started with. And so many consider this to be a waste that's created during the process. In the second flow diagram underneath, this is essentially a 3D printing or an additive manufacturing process, and the argument being that there can be material savings made when using 3D printing. We'll explore the benefits of AM technology in greater detail over the 2-day workshops. Some of these benefits range from shorter lead time to production flexibility to reduced inventory. This slide shows us some other factors that can be investigated as part of the workshop to identify possible benefits of AM. For example, complexity is often described as free with 3D printing. There's no extra cost to have complex designs. We'll look at the comparison cost between cost per unit of additive manufacturing and conventional manufacturing, and evaluating mechanical properties, of course, is a key factor. Traditional versus AM evaluation of mechanical properties is key. We'll of course consider different types of AM technology available, from FFF, lots of initials and acronyms, to vat polymerization, to powder bed fusion. We'll look at all the advantages and the techniques behind these processes. We'll look at the global market of 3D printing, the areas of growth and opportunity, and this will help us form an opinion of 3D printing as just hype, or is it really an opportunity, a technology that helps you gain a competitive advantage? This has been a very short 15-20 minute snapshot of what is a really large, bigger area of investigation, and we'll delve into these as part of the workshops. Hopefully you'll want to know more, and I look forward to welcoming you to the amazing facility that is Space Park Leicester on one of the dates. You can book now on the 3D Matters website. You can see there, and as I mentioned during the intro, we are offering a special discount today to webinar attendees. So an email will be sent out to you after, so you can claim this, and I look forward to welcoming you at Space Park Leicester. All that remains is to ask anybody if they have any questions. I think you'll be taken off mute, and questions can be asked. Anybody have any questions?
I have a question, please.
Hello, I can hear you. Does anybody have a question?
Yes. I want to ask, if I 3D print a metal part and I want a small location of the part to be less porous, So do you know if there's any post process to make to densify that location?
Yes, I mean you can affect the porosity of parts by the infill structure in some technologies, and again, different materials can have different porous structures. For example, in 3D printing of ceramic, ceramic is used in biomedical applications where the edge of the part needs to be less dense and more porous, so that the integration into the bone structure is possible. So yes, there are definitely ways to make areas of 3D printed parts more porous than others, but it really depends on the geometry that you're looking at, the material you're using, and the process that's being taken. But certainly we can discuss this in more detail.
Another question? Can I ask another question?
Of course.
So if I want to 3D print a aluminum part, what is the dimension accuracy you can control? For example, if the total unit is about 200 millimeter, so how accurate you can control the size?
So it really depends on the technology that you'll be printing with, but 3D printers in general range from 100 micron to 10, 15 micron. Generally, I mean, there are micro capabilities, but generally that would be the type of accuracy you'd be looking at in general. But there's a lot to consider in terms of technology you would use, the size of the part generally. You've mentioned 200 mil. So we'd certainly want to look into that in more detail.
Okay, thank you.
But perhaps we could take your particular application offline if you wanted to, and we could discuss this further.
Yes, sure.
Or of course join the workshops, and we can look at the as part of the consultancy, look at your particular application, because it sounds like you've got some specific ideas of what you'd like to produce.
Yes, sure. Thank you.
Thank you for your questions. Anybody else have any other questions?
Yeah, I have a question about the relationship between the melting temperature of additive manufactured resins and the actual operating temperature. Is there sort of a general guide as to what the difference between the melting point of the material would be and the actual operating temperature?
So obviously, again, it depends on the technology you're using, but let's assume you're using FFF or a filament going through a nozzle. Clearly, the filament's in a solid form, and that would go through a nozzle to liquefy or to make it possible to lay a layer of material. As we described in the webinar, each layer gets put on top of each other. So you would then so there's a melting point of the original material, and then of course there's an HDT, or a heat deflection temperature of the part once it's gone through those, once you have your physical form. If temperatures are a key factor, then certainly, as an example, the ceramic that we print using fused filament fabrication has a temperature of around 180 degrees. That's going through the nozzle. but then once we've got the formed part, we can debind and desinter that material. And once we've done that, the part itself is able to withstand temperatures of over 1400 degrees Celsius. So certainly there isn't a direct correlation between what goes through the process at producing the part to its HDT. So that there are materials that can be used for those types of hard-wearing applications, which sounds like what is something that you're thinking about.
Yeah. Okay. All right. Thank you, Nathan. Yeah, that
No
answers
problem.
my question. Thanks.
No problem. Anybody else have any questions? I think we might have exhausted the questions. So if that is the case, I'm not getting any indication anywhere that there are any more. Thanks again for your time. You'll receive an email, and I hope to be able to pick up very exciting ideas that you have at the workshops in the coming dates. So thanks again, and look forward to welcome you at SPL in the future.